MCT4C Day 5, subtracting vectors. If we recall the piano example from yesterday, and you have Keaton and Drew working together, we can simply add those two vectors by putting them tip to tail. If Keaton and Drew were to work somewhat together, but at a different angle between them, they're somewhat helpful to each other, and the resultant would be between the two. However, if they work against each other, if Keaton's working for all he's worth and Drew works against him, we know our resultant will be the one, and the one going in the opposite direction will take a chunk off of our vector, and we get a smaller, less helpful vector. If we have Keaton working like so and Drew working like that, our resultant will not be like adding vectors in between the two. It will be something rather different than that. That is subtraction of vectors, and we're going to look at that. So if we have vector u and vector v, and we want to add them, we would put them like that. If we want to have vector u and vector v and subtract them, then we would add them like that, because we are doing vector u and then we're doing v in the opposite direction, and our resultant will be like that. So this is v going in the opposite direction. So u take away v is right there. So to subtract vectors, we add the opposite, just like integers. This is another vector u. Here is another vector v. Come here, behave. All right, sort of. If we have vector u and vector v, and we were to add them, our result would be like that, where you have basically formed a parallelogram, and the resultant is the one diagonal. If you are subtracting, I twisted it a little bit. If you are subtracting, your resultant is here, which would be the other diagonal in a parallelogram. Let's draw that again so we can see it perhaps a little bit better. Vector u, vector v, vector u plus v, and u minus v. I have vector AC. So if you're using two capital letters, it's from tail to tip, sorry. Vector AC is AB plus BC. It's really nice when you're using capital letters because you start at A, travel through B, end up at C. From that statement, we can see that AC subtract from both sides, BC equals AB. If we're using our add the opposite principle, we have AC add the opposite of BC, which would be CB really, and our answer will be AB. For the next one, I have vector R plus vector P equals vector Q. From that statement, I can say that vector P equals opposite of R plus vector Q if I subtract R from both sides. Let's follow our diagram. R plus P is Q. Start here and here. And P is the same as the opposite of R. Add Q, and you do in fact get P. What you need to remember is that subtracting is adding the opposite. Let's do a question together that's out of your workbook, page 5612A. We have been given some forces. Force 1 and force 2 has a resultant of F1 plus F2, where F2 is 120 newtons on a bearing of 48 degrees. And F1 plus F2, the resultant, is 110 newtons on a bearing of 100 degrees. So we have been told that F1, force 1 and force 2 gives us the resultant that, just as we know from addition of vectors. We know that force 2 is 120 newtons on a bearing of 48 degrees. So I would like to draw him. So I am heading very bad north. I am heading north and turning to the right 48 degrees. So that is force 2. And I know my resultant is 110 newtons on a bearing of 100 degrees. So I have turned 100 degrees from this north, so past this right angle, down just a little further. And that is my resultant. I would like to know what force 1 is. I know that force 1 and force 2 is equal to the resultant. I also know that I can change the order so that force 2 and force 1 is equal to the resultant. So I'm going to draw my force 1 right there. In other words, my force 1 is equal to the resultant take away that second force. So I've got a subtraction. Let's put the values that we know. We know force 2 is 120 newtons. Force 1 is the question mark, and the result is 110 newtons. And we have our angles there. So let's find that force. We need to use trigonometry again. I want to know force 1. I'm going to have to use the cos law. The magnitude of force 1 squared equals 120 squared plus 110 squared minus 2 120, 110 cos. The angle between them. This angle is 100 minus the 48. 52 degrees. Make sure your calculator is in degree mode. Making brackets my friend, here and here, I have the magnitude of force 1 squared is approximately 10,246.5, which gives me the magnitude of force 1 as approximately 101.2. Does that make reasonable sense looking at our diagram? Yes, it does. We would like to come up with a bearing for this. I know from Z patterns, right at the top corner, there we are with my terrible north, that I have 48 degrees here and must also have 48 degrees in there. If I could come up with that entire angle at the top of my triangle, then I will know angle little green dot, which will tell me or can allow me to figure out a bearing. So I would like to figure out that entire angle at the top by using the sine law. I have sine 100 degrees over force 1, which is 101.2. Sine that entire angle, which I'm going to call theta, over 110. So sine theta, multiplying both sides by 110. Okay. There, this is good for me. I don't know if you saw my error or not, but I caught it. This is not 100 degrees. This is 52 degrees. There we go. Now my calculator's not swearing at me anymore. I have sine theta. When I type that in, I get 0.856 and so on. I do second function sine. If you have an answer button, that keeps all of the places behind the decimal and you don't lose any. I end up with theta is approximately 58.9 degrees. That tells me that my entire angle at the top of that triangle is 58.9 degrees. We knew that in the Z pattern I had 48 degrees. That means my little angle dot is approximately equal to 10.9 degrees. That means that force 1 goes from north and turns almost all the way south, but backs up 10.9 degrees and aims in that direction. That is a bearing of 169.1 degrees. $180, take away my 10.9, just checking my math here, 169. Hello. A bearing of 169.1 degrees. So force 1 was 101.2 newtons at a bearing of 169.1 degrees. Please read and make note of page 54. And then try page 55, 56. Numbers 1 to 8, 9 to 11, and 13.